In today's era, it is nearly impossible to imagine our lives without electricity. From lighting our rooms to connecting to someone miles apart, we need electricity. In this video, we will start by understanding the basic terms of the concept and then discuss an important relation known as the Ohm's law. Let's first understand the term electric current. The literal meaning of current is movement of something along a given direction. For example, water current means movement of water. In the same way, electric current refers to the amount of charge that flows through a conductor in unit time. Mathematically, electric current I equals Q over T, where Q represents electric charge and T represents time. Now you may wonder, what is this electric charge? Basically, electric charge is a property of electron or proton due to which they attract or repel. For a deeper understanding of electric charge, you can watch this video. The charges which flow in a metallic wire are electrons. However, these electrons were not discovered when electricity was first observed. At that time, electric current was thought to be flow of positive charges which are known as holes or kernels. The electric current due to these positive charges is today referred to as conventional current, and its direction is opposite to the flow of electrons. Electric charges have the SI unit coulomb, and electric current is measured in amperes. Now the question is, what makes these charges move? Let's understand this with an analogy. Consider this wheel placed on a flat surface. Does it move? No, because there is no difference in height between point A and B of the surface. On the other hand, if we had a wedge-shaped surface, the wheel rolls down. This is because there is a difference in heights at point P and Q. This difference in height gives rise to gravitational potential difference. Such a difference is needed for charges to flow as well. In case of electricity, this is known as the electric potential difference. Potential difference is defined as the amount of work done in moving a unit charge from one point to another. A battery is what creates this potential difference. Potential difference is measured in volts and is denoted by the capital letter V. Mathematically, V equals W over Q, where W represents the work done and Q represents the electric charge. Until now, we know two things. Number one, electric current is the flow of electrons in a wire, and number two, a battery provides potential difference for the flow of current. Now let's set up an experiment to derive a relation between these two parameters. We begin by adding a bulb to our circuit diagram. Now for this bulb to glow, we need a potential source, which is a battery. Next, we add a switch to our circuit so that we can control the flow of current. Now we wish to measure the value of electric current as well as potential difference across the bulb. So we connect an ammeter and a voltmeter to measure the value of current and voltage respectively. We will explore the reason why these instruments are connected differently in our upcoming videos. But for the time being, we have completed our circuit, and now if we close the switch, we can see the value of voltage and current. In our experiment, we want to explore what happens to the value of current if we continuously increase the voltage. So we replace our battery with a variable voltage source whose value starts from 0 and goes up to 10 volts. We want to plot the relationship between voltage and current, therefore we add this graph in which the voltage is along x-axis and current lies along the y-axis. Now on running the simulation, we see this straight line as the plot between V and I. But what does this mean? This means potential difference is directly proportional to electric current, meaning greater is the value of electric current, greater will be the potential difference across that conductor. This relationship was first observed by Georg Simon Ohm, and thus this relationship came to be known as the Ohm's law. Now if we take the ratio of voltage and electric current along multiple points in this curve, we see that they all come out to be a constant. This constant of proportionality is what we call as the resistance. It is denoted by R and is property of a material to resist the flow of electrons through it. Thus our relationship becomes V over I equals R, or simply V equals IR. This is the mathematical relation for the Ohm's law. The resistance of material also depends upon its length and area of cross-section. It is directly proportional to length of the wire and inversely proportional to the area of cross section. Mathematically, R is proportional to L over A. On removing the proportionality sign, we get R equals rho L over A. The constant of proportionality rho is called as specific resistance or resistivity. Unlike the resistance, specific resistance does not depend upon the dimensions of the wire, but only on the material of the wire. The reason why rho is called as specific resistance is because it is the resistance when length of the wire is 1 meter and area of cross section is equal to 1 meter square. In the end, I would like to express my gratitude to Team Simphy who helped us to simulate the experiments. Do check them out, the link will be in the description. So this was it for the video. See you in the next one. Thank you for watching.